Hi guys, and welcome to my video on surface area of a cylinder. This is a funky topic and we are going to get right into it just after a quick question. Have you subscribed to my YouTube channel? I know you're probably new and you haven't seen these videos before, but if you have and can subscribe, I would be deeply, deeply grateful. Very few people watch Maffs videos, and whilst I'm never going to be rich and I'm certainly never going to be famous, it's good to know that people are actually watching, and clicking that subscribe button just lets me know that people are watching this stuff and actually to continue making them. MaffsGuru.com is my website. All of this is over there organized by textbook, and there is downloadable notes, and there are exam style questions and all sorts of stuff over there for you to be able to use. Shall we get started? I think so too. I'm a bit over being needy. Learning objectives, yes, how we are going to draw the nets of solid cylinders. We need to make sure we know that for a cylinder that it has a net. And again, not that cheesy joke of that strange lady I found on the internet. That sounded even worse. Okay, know how to find the area of each section of a net of a cylinder and then find the surface area of a cylinder. Yeah, I'm gonna power through this because it's funky, it's awesome, but it's basically two circles and a rectangle. That's all you need to know, two circles and a rectangle. In previous videos, if you haven't watched them, they're on MaffsGuru.com, we have recapped the basic areas of shapes that basically form all the rest of shapes known to man. Composite shapes, for example, we can draw, as I've said before, a house, and this is my house that I live in, no doors, no windows, it's fine. But it's generally made up of a triangle and some sort of quadrilateral. Once we know that those basic shapes are there, we can find areas and perimeters and volumes if I need to, not of a 2D shape. And basically, that's what all of these videos are building on now. Now, my favourite sweet of all time is a jelly tot. Oh my goodness, Christmas. My nan, love her to bits, used to buy me 6 tubes of jelly tots every single year. Now, if you don't know what they are basically sugar, wrapped in sugar, coated in sugar. It's just sugar. It is literally just sugar. And the tubes are massive. And I used to be able to down one of those in about 10 minutes. The sugar high was something else. I was shaking. It was not probably very good for your teeth, your metabolism, diabetes, or any of those, medical conditions. But for Christmas, who cares? Jelly tots come in a cylinder. And one of the great things about jelly tots is that you can actually deconstruct the cylinder, because this is not a great admission, but actually once I finished eating the internal contents, I would generally start eating the cardboard. Yes, I know, eating paper, not a good thing. You've already stopped watching, haven't you? Yes, me too. So the great thing about jelly tots was, firstly, there was a plastic lid. And when you popped out the lid, generally speaking, there was a letter on the inside. I don't know why. Can you imagine eating 27 or 26 tubes of those? And interestingly, the end of that was a circle. And then at the other end of this, there was a cardboard insert pushed to the bottom of this thing that was, once again, a circle. And when you took those two things out, what did you get left? You got left the tube. Okay, so what I'm now going to do is a practical demonstration. Here is a piece of paper. It's a rectangle. And as I'm sure we've done many, many times before, you can roll these things up and turn them into a peekaboo. I do that to my daughter all the time. It's a little bit too weird, isn't it? But if I actually turn this around, what do I have? I have a cylinder. Yeah, now we've done this loads and loads of times before playing. But what we notice about our cylinder is, what do you see about the outside? Well, it forms a circle, which when I flatten out, and I'm going to make it flat, forms one of the lengths of a rectangle. And that's actually how they make cylinders. They take a rectangular piece and they just scrunch it up. They fold it up, glue it together, job done. Probably not as simple as that. But what's important to notice is, at this moment in time, what do we call the outside length of a circle? Well, what would we call the outside length of a circle? Circumference. And so what we know is that the circumference of our cylinder happens to be one of the lengths of our rectangle. And we know the other length here, because that's going to be, if we fold it back in again, that's going to be the length of my tube. So going back to my diagram, we know that length. We can be given that length, but to find, once we roll that out into a rectangle, to find this length here, we simply need to know that it is the circumference of that circle. Oh. Now, we know how to find the area of circles. Here is a circle. We need to know a radius. They can give us a diameter. Remember, our diameter is equal to 2 times the radius, or my radius is equal to diameter divided by 2. So if they're given the diameter, just halve it. And to find the area of this, as we say, we do pi times radius squared. These formulas should be in your summary book. So automatically, if I have a cylinder and there is a visual representation of a cylinder, I now know I can find the area of that end and the area of that end, because the cylinder is going to be the same thickness or width or diameter all the way through. So that's fine. But how do we find the dimensions of that rectangle? Well, as I've said before, we now know that if we have the rectangle here, we know that this is going to be my length. And this here is the circumference of the circle. And so what I'm going to write there is we know that the circumference of a circle is 2 times pi times radius. And so we know this is 2 times pi times radius. Now, imagining we don't call the length length, we call it h for some random reason in mathematics that I don't fully understand. I mean, at the end of the day, I suppose if you hold a cylinder one way, it's a length. If you hold it another way, it's a width. Another way is a depth. But anyway, so we now know that the area of that sort of curved surface, notice the word there, curved surface, going to come up, is equal to, so the area of this is 2 times pi times r times h, which we can write simpler as 2 pi r h. It's going to become important. So, I know lots of you find formulas amazing, but I'm going to caution you here, because if you get the idea that the surface area of a cylinder is a formula, then you're going to start making silly mistakes. I always do this from first principles. I always go circle, circle, cylinder. Leave it at that, job done. And I'll show you why in some questions in a moment. But there is a formula, and you may see it in questions, that says the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. Hold on a moment. We've seen that 2 pi r h before. Yes, this here is the area of the curved section. So that's the area of the curved section only, and some questions will ask you to find the area of just the curved section. What on earth is this? 2 pi r squared. Ah, if I do pi r squared for one end and I add pi r squared for another end, then I'm going to get 2 pi r squared. So that there is for the two ends. Now, again, learning a formula, fine, I get it. But what if they tell you that one end of the cylinder is open? Well, again, if you notice that one end of the cylinder is open, that means there's only one circle. And so I tend not to use this formula unless I absolutely have to. So we'll use the formula for now. But let's look at this question here. So we now know that the surface area of this is equal to 2 pi r squared. Again, I just know this formula because I've got a circle plus 2 pi r squared, plus the curved surface area was 2 pi r, which was the circumference, times the height. So realistically speaking, this formula tells me I need to know the value of r and the value of h. Do I know the value of h? Yes, it's 25. Do I know the value of r? Yes, it is 5. And so, what do we get? We get the surface area is equal to 2 times pi times r, which we've got 5 squared, plus 2 times pi times r, which is 5 times that, which is 25. Can I do this in my head? No. Will I fire up my calculator? Yes, I think I will. So 2 times pi times 25, I'm just going to do that in my head, plus 2 times pi times 5 times 25, which is 125. I could have done that in my head as well. Gives me the staggering value of 942.48. And what were my units? Meters and squared. So my surface area there, 942.48 meters squared. That's using the formula, right? Lovely, if we can. Same though. If I was to do it in a different way, let's find the area of one of the circles is equal to pi r squared. We know that that is now pi times 5 squared, and the area of the rectangle is 2, or the curved section, times pi times r times h, which is 2 times pi times 5 times 25. Now you're going to say, but you're doing exactly the same thing. I know I am, but I'm doing it by thinking about the actual shape they've given me, so that later on, if they just tell me just to find the curved surface area, I know what I'm doing. So the total surface area then is equal to, well, that's 25 pi, writing it as an exact value. This here is 125/250 pi, writing it as an exact value. And if you don't know what I'm talking about with exact values, previous videos. And so the total surface area is 25 pi plus 25 pi plus 250 pi, which is 300 pi. Now I can fire up my calculator, and again, they may actually ask you to leave your answers in exact form. That's okay, so 300 times, oh, why do my fingers are so fat in this? 300 times pi, hit enter, and gives me, oh, that's lucky, 942.48 meters and squared. Would have been awkward if that hadn't tied up. Parts of a cylinder. Now, this is what I'm talking about with regards to the formula. Yes, in this situation, well, there were two ways of looking at this shape. The first way is to look at it as a whole cylinder, which has effectively been cut in half. Now, you have to be careful with that because you're going to find the surface area of half a cylinder. But like in previous examples, do you remember when we had to find the perimeter of a semicircle? And we worked out that we could actually halve the circle, which gave us this bit, but we still had to add on that sort of length there. Same here. I would then need to make sure that I added on that value there because you've got the base. So let's do that. So we now know the total surface area of a full cylinder is given by 2 pi r squared plus 2 pi r h. Now, I'm happy to use the formula here because I know what the formula is. So do we know the radius of our cylinder? Well, they've given us the diameter, which is 4 centimeters. So I know the radius is going to be 2. So that's 2 times pi times 2 squared plus 2 times pi times 2, still the radius, times the height or the depth, which is 8. Now, again, that's going to give me the whole cylinder, but I don't have a whole cylinder. Firing up my CAS, let's do 2 times pi times 4, because I know that's 2 squared is 4. 2 times pi times 2 times 8. Yeah, I could have done that one, I know. Which gives me 125. Now, again, a word of warning. My CAS is clever enough to give me all of the information. I don't know what the units are there. Let's just check what the units are, centimeters. So that's going to give me centimeter squared. That's not my final answer, and I only round out my final answer. So in which case, the total surface area, let's not put total, the surface area of my shape, whatever we want to call it, is now going to be 125.663 ... divided by 2. So I'm going to divide that by 2, hit my answer, which gives me 62.83185 ... Is still not finished. Because if you remember, all I've done now is found the surface area of this curved bit here. So that curved bit there, this end here, and that end there. We haven't found the surface area of the base. How am I going to find the surface area of the base? Well, the surface area of the rectangular bit is just 4 by 8, which is 816.32 centimeters squared. Don't need my calculator for that, but I can now say, therefore, my total surface area for that shape is going to be my previous value of 62.8318 ... plus 32, which gives me plus 32, 94.83 centimeters squared to 2 decimal places. And now it's perfectly acceptable to round to 2 decimal places. We've got to be very careful in maths of gotchas, all right? And these are the questions that are like, Okay, so we got a gotcha. So our first gotcha here, finding the surface area. What they've basically got is they've got a cylinder and they've taken out a cylinder as well. How are we going to find this? Well, very good question. Firstly, we can find the total surface area of that big cylinder. So I'd be finding the total surface area of that big cylinder. Then what I'd be doing is I would be saying, well, okay, I now have to subtract the area of that little circle and the area of that little circle, because that's now going to be taken away from my total surface area. But then I've got to realize I can now have a surface inside my shape. So this section in here, actually, all I'm interested in for that particular section is the curved surface area. So I would find the total surface area of the big cylinder, subtract the 2 circles at the ends, the 2 smaller circles, and then find the curve on. This shape here, composite shape, basically, again, we've got very similar to what we had in the previous example. I'd have that total curved surface, so I could find the area of my total cylinder and halve it. In this situation, I wouldn't have to add on the base, would I? Why? Because it's hidden, right? We're looking for just the surface, not that base anymore. And then with this cuboid here, I could find the area of the two ends, the front of the back, and the bottom, and add them together. This question here, I think, sadly, doesn't look particularly great in terms of a drawing. What I think it's supposed to show is it's supposed to show some sort of wedge, a triangular wedge, which we can find the surface area of quite easily. And then we've got some sort of cylinder here, or some hemicylinder. I don't know what half a cylinder is called. I'll have to look that up. Some sort of half a cylinder that we add together as well. So composite shapes, just taking it that one step further. And then this question here is an absolute doozy. Love this question. How would you find the surface area of this? Well, basically, it's now going to take all the maths you've done before and tie it in together. So we've got here a sector at the top and the bottom. We've got rectangle here and a rectangle here. That's nice and easy. But how are you going to find the curved section outside that shape there? Well, I'm going to leave that one for you to think about, okay? Because it is awesome. Can you see different ways of doing this question? If you can, try it in different ways. If not, give it a go. The worst thing you can be with these questions is right. Yep, I'm just going to let that sink in. Why is that a bad thing? Well, obviously it's not really a bad thing, but you learn more by getting things wrong and asking for help. So my advice to you is have a go, and if you can't do it, get in touch with someone. Show it to your maths teacher, show it to anybody who's got a maths brain, and ask them to help you solve it. And ladies and gentlemen, I am done for this video. Thank you very much. If you haven't already done so, I keep saying this, can you head over to my YouTube channel and subscribe? It just lets me know you're watching. Nothing more, nothing less. But I'm going to head off to record another video. So you have a good day. Please stay safe, and I look forward to seeing you again.